I want to talk about the concept infinity, because it keeps popping up in my videos. Infinity is one of the least understood concepts in life. It usually boggles the mind just thinking about it. Mathematicians, physicists, and philosophers all use the concept infinity. You may have heard the term infinitely long or infinitely large. The universe is infinite, but then cosmologists talk about the beginning and the end of the universe, and the edge of the universe, or outside the universe. People may sometimes mean very large or very long when they talk about infinity, and the term infinity is used very loosely sometimes. This causes mathematicians to tear their hairs out. Infinity means having no limit. So in this video, I would like to discuss infinity from a mathematical point of view. Albert Einstein once made a joke about black holes and said that they were created when God divided by zero. It is sometimes said that you get infinity by dividing by zero. And if you've had mathematics, you would know you can't divide by zero. Why not? Well, for a start, you don't want to create a black hole and get sucked up. Only kidding. You can't divide by zero because you get a nonsense result if you try to do it. The reason is that division is the inverse of multiplication. If you divide by zero, you should regain the number you started with if you then multiply it by zero. But by multiplying any number by zero, it produces only zero, not any other number. So this is a nonsense result. You can't divide a real number by zero in mathematics. So you can't divide by zero and get infinity, simply because you can't get infinity. However, you can divide a number by a number that approaches zero, and so approach infinity. This is called a limit. You can just keep dividing by smaller and smaller numbers, and so get a larger and larger number. And you can do this infinitely. In other words, you just have to keep dividing until the cows come home. And unfortunately, they never will. Infinity is not a number you can count up to. If you could get there, infinity is no longer infinity. It is finite, and any finite number is infinitely far away from infinity. So now we know that infinity is not a number, and infinity is not large. Now I'm going to confuse you even more, but bear with me. It will make sense in the end. Even though infinity is not a number, it can still be treated as if it's a number under certain circumstances. Infinity plus infinity is infinity. Minus infinity plus minus infinity is minus infinity. Infinity times infinity is infinity. Minus infinity times minus infinity is infinity. And minus infinity times infinity is minus infinity. And for any number, x is more than minus infinity, but less than infinity. However, you can't divide infinity, or say infinity minus infinity is zero. Why not? Well, this is because we don't know how big infinity is, and not all infinities are the same size. Huh? Did I say how big? Yes, infinity comes in different sizes, and some are countable infinite and others are uncountable infinite. Confused? I will explain. You know what a set is in mathematics? A set is a collection of objects. It can be anything. Apples, pears, elephants, or just numbers. Say you have two sets of objects, and you wanted to check if they are the same size. You don't have to count them, you just pair them up, and if you have none left over in the end, you know that the sets are the same size. Easy. The size of a set is called cardinality. Sets with the same size have the same cardinality. You could also count, using the natural or counting numbers. 1, 2, 3, etc. We are now pairing these numbers up with objects. Now think of a set with an infinite amount of objects. If you want to count them, you could start at 1 and continue counting forever, because the set is infinite. There are infinitely many natural numbers. Also, if you start at 1, you know you will not miss any number on the way up. Although you will never count all the natural numbers, you can just keep counting in a logical sequence without leaving any behind. So this is a countable infinity, and it has the cardinality aleph-null, and this is the symbol for aleph-null. Okay, now we're going to try something else. If we wanted to count the whole numbers, 0, 1, 2, 3, etc., does this have more numbers than the natural numbers? You may think yes, because it has 0 as well. But what is infinity plus 1? Still infinity. Let's start counting. If we pair 1 with 1, 2 with 2, 3 with 3, and keep doing this infinitely, you will leave 0 behind. And because this set is infinite, you can never come back to count 0. Here, a very clever mathematician called Hilbert came up with an idea. He created the Hotel Infinity. The Hotel Infinity has infinitely many rooms. It's a very popular hotel, and it's always full. Every room is occupied by a guest with a natural number on his t-shirt, and you can't have more than one guest per room. Now a guest with the number 0 on his t-shirt wants to check in. He asks if he can have a room in the hotel, and the receptionist tells him that there are still rooms available. In fact, there are infinitely many rooms available. How can this be? The reason for this is because infinity plus 1 is still infinity, and adding any extra number to infinity still makes infinity. The guest can't walk to the last room, because the hotel has infinitely many rooms, and it would take forever. So the receptionist just asks every guest to move to the next room, creating a vacancy in room 1 for the guest with the number 0. So here we can see by matching guest 1, guest 0 to room 1, guest 1 to room 2, and guest 2 to room 3, and etc. We can pair up the natural numbers with the whole numbers without leaving the 0 behind. The two sets have the same cardinality, and they are countable infinites. What about the set of integers? -3, -2, -1, 0, 1, 2, 3, etc. We can see that these numbers go off to positive and negative infinity. If we started counting at 0, we would never be able to get back to count the negative numbers. So we have to be a little bit more clever if we wanted to count every number. We can rearrange numbers like so: 0, 1, -1, 2, -2, 3, -3, etc. We would not leave any number behind, and again we can merrily count until the cows come home. And we know from before that we can count until we are blue in the face. So the integers are the same cardinality as the natural and the whole numbers, and they are also countable infinite. But wait, there is more. What about the rational numbers? The rational numbers are all the numbers that can be written as a fraction of two integers, p divided by q. So 1 divided by 1 is a rational number, and so is 1 divided by 2, and 1 divided by 3, etc. So how many fractions are there between 1 and 2? Right, infinitely many. So if you started counting at 1 divided by 1, 1 divided by 2, 1 divided by 3, 1 divided by 4, you can see that the fractions keep getting smaller and smaller, and you will never even get to 2. Because there are infinitely many fractions just between 1 and 2, does this mean there are infinitely many more fractions than the whole numbers or integers? I'll put my thinking cap on. Let's have a look. Write all the fractions in the table like so. Now we can see that the fractions go off to infinity in 2 dimensions. So the rational numbers are in fact infinity squared. Can infinity squared have the same cardinality as infinity? The answer is yes. If you move along the fractions as follows, you will be able to count them all without missing one out. So we can conclude that there are as many fractions as there are natural numbers, whole numbers, and integers. The rational numbers are also countable infinite. Now you may be getting excited and say that every infinity is countable.